Standard function 4, still comparing functions. The learning target we're looking at is I can compare properties of two functions that are represented differently. So that means it could be a table and a graph, or a graph and an equation. But the difference between LT1 and LT2 is LT2 doesn't say it has to be proportional. So we could be looking at a proportional table and a non-proportional graph. So you need to be careful of when you're comparing that you know which kind you're comparing with. So little vocab here. So the rate of change. So when comparing functions, we really look at that rate of change. So as we can compare functions by looking at their properties such as, I'm going to write the word slope in here, or rate of change, and I'm even going to add or unit rate, because sometimes taking it down to the unit rate is a good idea because then they all have a denominator of 1, so it's easier to compare in the numerator. To find the change or your slope, I'm going to write down here so we can see it. y2 minus y1 over x2 minus x1. So if there are points, you could use the formula, or you can compare, if it's a graph, a lot of times you can use rise over run really easily to see. So our first example says Jay and Nathan want to know who can run faster. Jay even gave Nathan a 4-meter head start. The graph shows the relationship, or the distance, per second that Jay ran during the race, and the data set, known as the table, shows the distance per second during the race. So we'll start with Jay's here. Jay's is a graph, and so our goal here is to compare them. I think our question, if we look here, is who ran a faster rate, and I need to show all my work. In other words, show what you're comparing. So I'll do my work over here off the side so I can keep the graph and table in view. So we're going to start with J. So we're going to find the rise over the run, or the slope, other words, or we can use a formula. I'm just going to use rise over run since it's in a graph mode. So remember, you go rise, a vertical change, over a horizontal change. So if I look at that, and I got to look, this is 2, 4, and then 6. So this is 6 meters over 1 second. So J is running 6 meters in 1 second. Again, I looked at rise over run, how much increasement on the vertical distance over the horizontal. Nathan, and by the way, that is proportional. This one I can tell is not proportional because it doesn't go through the point 0, 0. So I can't go 9 over 1, because notice if I go 9 over 1, that's not the same thing as 14 over 2, because that'd be 7 over 1. So you can't just go y over x. You need to look at the change, or you can use the formula y2 minus y1 over x2 minus x1. I'm just going to use the change in the table here. So remember, this is our x. You can see that down here. X represents seconds, and our y represents meters. So the change of the y goes on top, which was 5. I'll put a label there, meters, over the change of the x, which is 1 second. And that's the change of the x. So when we compare these two, we can compare them now, and it's nice because you can have them both in a unit rate. So if you look at this, 6 meters in 1 second, so that person goes 6 full meters, so think of a meter stick, 6 meter sticks in a second, and Nathan can run 5 meters in a second. So who runs a faster rate? That's definitely J. So now we're going to write our sentence here. So J runs 1 meter per second faster than Nathan. And then the work is right here to prove that math. The second example here, we're going to compare an equation to a table. So the storyline is Bobby tested his dad's truck brakes. The truck will stop at a rate represented by the function y equals negative 8x plus 40, where y is the speed in miles per hour and x is the time in seconds that he pushed on the brakes. Bobby also tested his brother's Mustang, and the data is shown in the table below. So we'll start with the truck. We'll do the work down here because there's not a lot of room. So the truck's an equation, which was y equals negative 8x plus 40. So non-proportional because it's not going through 0, 0. We're going to look at the slope. And in the equation, it's nice because the slope is sitting right in front of you. So the slope is negative 8, and then over 1 to make it look like a ratio. So the question is negative 8 what? So if you go back up here, why is the speed in miles per hour? So the label on negative 8 would be miles per hour. And 1 says x is seconds. So in 1 second. So he slowed down 8 miles an hour in 1 second when he pushed on the brakes in the truck. The Mustang this one's in a table, so we can do a little bit more work. I'll just do y2 minus y1 just for something different here. So this, we call it x1, x2, y1, y2. You need to label, make sure they are in partners. So if you do, I'll just put the equation here so you can visualize it. So y2 is 19 minus y1, which is 55, over x2, which is 5, minus x1, which is 2. So 19 minus 55 is negative 36, and 5 minus 2 is 3. So we could say this, if you reduce, because we want a unit rate so we can compare them in the same format. So negative 36 divided by 3 is a negative 12 miles per hour in 1 second. So now we have them both in the same format. Now we can discuss the question here. Which vehicle stopped at a faster rate? Well, it's going to be the Mustang because it went down 12 miles per hour in that second, and the truck only went down 8. So we can write the sentence. I'm going to write it up here. The Mustang will stop at a faster rate by 4 miles per hour / 1 second. And again, when you write your sentence to answer this question, know that you don't have to have a certain way to write it. Just write it whatever makes sense to you to explain, first of all, who is faster in this case, and who stopped faster, and then by how much, because that tells me that you compared the two. And comparing, for example, if I said, I have more money than you would compare how much money I have and you have, and you could talk about how much difference there is. So that's what I'm just saying. If we have negative 8 miles an hour per second and negative 12 miles per hour per second, well, this Mustang is stopping or faster at a 4 miles per hour per second difference.